I'm happy to continue talk about the programming technique of grade 3. This time we'll start a new topic. This topic we will talk about how to program the new distributed node. I call it peer. It's a new distributed node. I think I'm not sure whether you understand this concept or not. I think peer, this node, is very important for us to distribute it or implement a scalable distributed system. If a system, distributed system, one of the important feature or if we want to evaluate the quality of distributed system, the scalability. Scalability is a very important character to evaluate whether such a system, the quality of system is high or not. If not scalable, that means it's impossible for such a system, or it's difficult for such a system to process high volume incoming task. So it's necessary for us to design a scalable system. But do you think the system we created before, the TNCS or MNCS, do you think such a system is scalable? No, they are not scalable. In such a simple system, only one server is available, right? All the burdenness, all the workload, all the heavy burden have to be put on such a server. So such a server have to deal with all the incoming messages, all the clients, no matter no matter what is how large the number is, the all the server have to deal with all the incoming messages, all the helium, how all the data from the client. The server has to process all the data, messages, tasks by itself. So it's impossible, right? It's if a system is simple, that's fine. But if the system is complete, if the system runs in a internet-based computing environment, even for enterprise level distributed system, it's also impossible. So we have to design a new system. In such a system, if incoming messages, if incoming tasks are heavy enough, it's possible for such a node to forward to forward the incoming message to other distributed node. That means the scalability or the scale of the system can be enlarged. That's very important, right? That means scalable. The scale of one system can be enlarged. So TNCS, MCS, for such a system, I don't think such a system is scalable. So only a single node of the server can process all the incoming messages or tasks or data. So you have to design a new programming component to deal with this issue. That's why we need to propose the concept of peer. So here for this class we have to talk about some concepts, but in the next classes we have the most important feature for this class is we need to program. We need to show our ideas through programming. online programming, not just talk, right? So here we introduce some basic concepts. Actually, here you can see this sentence. The peer plays both of the role, the client, the classic client, as well as the classic server. That means a peer is the client plus the server. You can, I think that's a basic idea. I think most developers or software engineers who are interested in the distributed system programming must know this idea, right? Know this concept. So if we want to design a peer, we just need to combine the server and the client together. But my question is, how to do that? Is a convenient way? Is there a convenient way for us to implement a peer? Sure, because we already have DP, right? DP is the distributed primitives, right? We already have the very important distributed programming techniques that can help us to programming a peer, to implement a new API. All the APIs other than DP, all of the other new APIs in GridFree are called advanced API. The acronym of such API is AA, double A. So if you want to implement a new AA, usually, at least according to my current experience, all the advanced API can be programmed with DP. All the advanced API are originate from DP only. Originate. That's a very important point of view from I think that's also a very important feature for GridFree. So that's why GridFree is self-contained. So a self-contained system means that if any other distributed programming component are not available in such programming paradigm, it's possible for us to using the existing APIs of programming components only to design such unavailable programming components. That's the meaning of self-contained. Until now, I haven't discovered or I haven't found any other programming paradigm have such a feature. We talked about this issue before, right? Okay. So if so, what we can do, how we can program. So next, in the next I will talk about how to program such API, the new API. We call it a peer. So with this API, we can program scalable system. Okay, maybe we have talk about this issue, right? MSS is only have a single server, so it has to tolerate entire workload of the system. So the server become bottleneck to raise scalability of system. We talked about this issue before, right? Okay. This is talk about the necessity of the peer. The workload of server cannot be balanced to additional distributed node in MSS. Yeah, because the server is a CS server cannot forward. That's very important drawback of CS server. That's also a very important feature of CS server. So I have to change it. Okay, so although I think we have to talk about this issue, right? The scale of MSS can never be enlarged. Okay. And for the same token, a large scale system further distribute nodes with accept task from the call node, the peer, should be turned into peers as well. So, all in the near, that sentence means in the near future, we will see some large scale. We will focus on large scale distributed system, right? So, if we want to enlarge a system, do you think there means there are a lot of computers within such a system? What distributed node, what distributed model for all of these distributed nodes in such a large scale distributed system? I think the node should be peer. All the node, or at least most of the node, within for a scalable system should be a peer. So at least most of them. We will show some example in the later classes. That's a sentence, right? What that sentence means. That means CS server, this API, or this programming component, I'm sorry, can only be used in some simple system or unscalable systems. So in such a system, a scalable system should be a peer-to-peer distributed model, right? Any distributed system that can be scalable must be a peer-to-peer distributed model, P2P, rather than client server. I think most of the developers know the term, familiar with the term, I'll say client server. But I think P2P is more important. Because we need to enlarge the scale. Using P2P architecture, it's possible for us to design a system whose scale is infinity. We need to define infinity system. Do you still remember the system I mentioned before? Global scale, heterogeneous, maybe socialized distributed system, socialized system, distributed system. I think such a system is the most difficult one of the world. So the final target, the final goal for GRID-free is to implement such a system in a high efficient way. That's what I want to do. That's what the final goal of GRID-free. If GRID can implement such a difficult system conveniently, that means GRID-free is successful. Yeah. Okay. So, but peer-to-peer, the peer is this distributed model, the P2E model, or this distributed node is very important. Then in the future, we'll talk about multicasting, clustering. If no peer is available, all the issues, all the important features for distributed system programming cannot be implemented. So we need to implement the peer first. So peer is very important. So that's why we need to implement such a new programming model for this class. Distributed caching, right? We also need to design such a API. There are a lot of advanced API should be implemented, but almost all the API is based on the model of peer. Registry, we'll talk about another concept, registry. I'm not sure whether you have such an idea or not. Registry is very important. Actually, any distributed system have such a concept. I think a concept registry is can be defined like this. I think any system there are a lot of computing resources for any distributed system. So if we want to share to access all the computing resources, we must have a mechanism. In such a mechanism, all the computing resources that can be shared within a system can be accessed, can be retrieved, can be even modified based on such a registry service. So the registry service means all the computing resources that are available for us to access can be visible, can be visited, accessed, can be retrieved in such a mechanism. That's the means. That's the concept of registry. So any system have such idea, but what about TNCS and MCS? Yes, I think even in such a system, TNCS, MCS, there's still a registry, but because such a system is too simple, so the registry service in such a system is degenerated to the single server. So that means we do not need to design additional registry. We just reuse. We can because only one single server is available. The single server is the only computing resource we can access. So that means it's not necessary for us to design any registry. So the registry is degenerated. So that the single server can be regarded as a registry. The single server is not only computing resources all the clients can access, but can also be a registry server for use for other clients, right? To retrieve some computing resources. So it's not necessary for us to design additional registry for such a simple system. So that's why we do not talk about this idea before. However, for this time, because we need to design large-scale distributed system, so we need to enlarge the scale of such a system, so that's necessary for us to design such a system, right? So when we show something system that based on the P2P distributed model, you can see registry server should be started before the entire system is can be executed. So this is the idea of registry. You can see the definition I wrote here. Registry in the domain of distributed computing specify the fundamental service to collect all the distributed resources in a repository, such as DB or some, for simple system, maybe there are no DB. DB is not necessary, but for large scale system, maybe the computing resources is is rich. We need to save the data on some persistent mechanism such as database, such that the resources can be located. Located means we can retrieve, we can find the resource we need and shared. All the resources should be publicly accessed by a large number of users or clients or other peers. So we need to find them. So that means share, right? To form distributed system. So the registry is very important. I can give you another idea. What about the internet? Oh, why? 3W. Any registry service on World Wide Web? Yes, I think maybe search engine such as Google. Google is one type of registry service. I think you must know about. We just talk about this system: global scale heterogeneous socialized distributed system. In such a system, which one is a registry? How we can define? How can we define a registry service for such difficult system? I think maybe classic search engine like a Google maybe is a one choice, but I don't think it's good enough. I have investigated, done a lot of research on such field. I don't think Google-like system can perform or can fulfill the requirements for such difficult system, because system is huge and a lot of the infinite number of users, unlimited computing resources, computing devices, various data. So it's impossible just using such a classic, so-called classic search engine to deal with all the issues. We have to design some new features. We need to understand this search system deeply to design a mature social some registry service for such a system. It's difficult. I don't think a perfect algorithm have be proposed for such difficult system. This is another point. This is another issue, right? So we do not need to. We have no time to talk about this issue. But I think I just when I talk about this issue here, that I want to tell you that registry service is very important for any distributed system. But because right now our system is very simple, so the system I will show some simple example for registry. So for our system, it's very, very simple. Okay. Let us talk about here, right? For our system, that because we just for the system that is not so difficult for our system, we can only use CS server to design such registry server, right? Registry service, because for such system, our system is simple, so all the computing resources is still are still not so huge, right? So we can just use a single distributed computing devices, a physical standalone physical distributed computer, and to convert such a system to a CS server, and then publish or register all the computing resources to such a system. And then at this time, the service for such a system, the interaction between such a system is also simple, right? So when the multiple peers need to interact with each other, they just need to know the IP address of the other peers, right? If one peer need to access each other, they just want to know the IP address of the peer. If peer A want to interact with peer B, then the IP address is necessary over the internet, right? So for such a, at this time, for our registry service, it's very simple compared with the Google or some other system. Such a system that I just mentioned, we have no perfect design for such system. We still need to do a lot of research on this topic. So for such system, it's easy to be designed. You just use CS server. I can show you an example here. For our class, it's very important, right? We need to, because I want to show you the code. Okay. Let us open here. This project is here, right? Here. I'm sorry. You can take a look at the package name. You can find the code according to the package name, as we have done before. Here, right? Peer, P2P, you can find here, P2P, right? DIP, you can miss it, so that before this, in the previous classes, DIP means distributed framework. You can understand this acronym in this way. And here you can see this is peer, right? We will see how to program this system in the later classes. Here, registry, we can take a look at this code. Okay, this is registry. Okay, start a new window. This is the registry. Okay, I open this package here as well to make a comparison. I'm sorry. Here, we take a look at the multiple node. This is a server we programmed before, right? So we can take a look at this server here. Now this is registry, right? This is registry we implemented for the peer-to-peer architecture. You can see this is the starting point. Starting point is the first design pattern in DP of grade 3. Then you can see here, it's the same. The pattern is same. Then now we need to let us open this one. Okay, we see this code before. We open this one. Okay. This is the CSS pattern, right? CSS pattern. In this pattern, 2 instances of the server is created, and then a singleton is created. Then we can start this method is used to stop the server if we need. And then this method is used to start initialize the application level code and initialize the instance of the server and start the server here, right? However, for this one, This is almost the same. At least the structure, the pattern is follow CSS server exactly, right? However, for this case, there are three instances of the CS server. This one is fundamental. Do something for the fundamental peer-to-peer registry service. How this one is designed for chatting, because this one is designed for chatting. We'll show this demo later, right? This one is for management. So because you see this instance of the CS server, that means if you want to design one particular application, distributed application, you need to design, you need to change register server. So each different distributed applications have different requirements to share resources. So if so, the register server need to be modified depending on the specific requirements. So at least, although there are three instances here, I think the structure is the same, right? The structure of the design pattern is same. This also follow this pattern of CSS, right? Here you can see here some application level stuff are shut down or disposed, and the three instance is stopped. And here we need to initialize the three instance, right? And then different from this one, there's some application level stuff. It should be done here. We need to perform some tasks that related to registry service for the peer-to-peer architecture. I don't want to talk about it so detailed at this time. So next time, when we run this code, I want to explain that. Okay, so at least you can understand this code as regard this code as application level initialization, right? Over here, you can see here, that's the same, right? The three instances of the CS server should be started. Then the server started. Okay, let us take a look at this one. The register server. Oh, not register server. The CS chatting server registry. The dispatcher. I'm sorry. This one, peer registry dispatcher. For this case, only for this one, there are notifications to be processed, right? So notification dispatcher is put here. However, for this case, all the messages are in the form of request response. So no notification is declared here. But it doesn't matter, right? I think these two server, this one is REST server, this one is server for the chatting, is a server for the TNSS or MNCS, right? However, the server, the code structure is the same. The API are the same. All the APIs are originated from DP here for the register server, right? And the pattern is the same. So at least, although this example is simple, it proves that just for this case, at least the DP is a generic, right? So we do not use any other distributed techniques to implement such a register server, right? So that prove one, at least in that case. We have a lot of cases in the later classes. We have two. I have two prove the generic generic feature of grade free in all the entire classes. Okay, let us take a look at this one. This is a thread. To process incoming request. That's the same. I think you have already know how to program such code, right? Although maybe you are not familiar with register service, but I just explained the concept of register service. So if you have sufficient knowledge how to implement the register service for your specific applications, you can implement such a system using grade-free DP only. And that means DP or degree-free techniques is good enough for you to implement your register service. I think this is a good example for here, right? So at this time, I don't want to explain the code in so much in detail. Later I will explain that. At least the basic function for such a service, for the basic peer-to-peer architecture, it's just only collect the IP address, all the IP address, all of the IP addresses within our P2P system are registered on the register server. Right, so that's very simple register service, right? Okay, that's the idea of registry. Okay, so we talk about these issues. Okay, next. Next we'll talk about essential to program the peer. So if we want to program a peer is a new AA. AA means advanced API, advanced more complicated programming component to deal with a new issue in particular computing environment. And that's so if you want to design such a peer, such a new advanced API or AA, you must gain distributed knowledge. You must know how the running mechanism within such a distributed computing environment, right? You must know the principle, how we can schedule the knowledge, schedule the computing resources or threads, concurrency issue, how such a system is organized, what about the scale, how to get a load balancing, solve the issue of load balancing. So you need to know, gain some knowledge. For another example, I want to, because I do a lot of research in such area, so I need to know why such a system is called socialized. What does socialized means? Why system is heterogeneous? How to handle that? After that, we can design such a new advanced API, right? If we have no idea about the principle, the mechanism, the nature for one particular system, it's impossible for us to design a new API to deal with all the issues. So the first step, you need to gain knowledge. You must have enough knowledge about your system. No one can help you on this issue. If you have no enough knowledge, nothing can be proposed, right? So this is the first issue. Fortunately, after you have already have sufficient knowledge, you can program with grid free. That's very important, right? So grid free can help you speed up the distributed system programming, but you are still required to have sufficient knowledge. So then, for our case, this you need to know what is a peer, why we need to have peer, right? We just mentioned that why peer is so important. We talked about this issue before. So after then you have to understand at least the peer is we need to have a registry, right? Service for such a peer-to-peer detector, and then we need to know the peer is a combination of the client and the server, so that such peer can not only deal with incoming message, but also it can forward the message it cannot process because of its limited computer resources, and forward such a message to its counterpart or to its friends or to its other additional peers to help it to processing such incoming message. So you need to have such ideas. This is the knowledge. Then after that, we can program it. So knowledge is the first issue, right? So it's easy to understand. It's common sense. Now we necessary. Next step in the necessary to evaluate whether existing DPAA framework are sufficient to. It should be easy to understand, right? And for this case, if the existing DP or advanced API or frameworks are not sufficient to do that, you have to propose something new, right? For our case, because we want to enlarge the scale of the system, so we have to design peer. However, you can see here the peer is programmed with these three stars. The first one is a CS server. Another one is a CS client. You must have. We haven't talked about this one. CS client. This is the first time for you to see such API. We talk about this one. CS server, right? CS server is we talk about it a lot. But the CS client is for this the first time for us to talk about. So what does it mean? CS client is easy to be understood. I'm sorry. It's a combination of it's a combination. It's aggregation. It's aggregation. Think of straightforward, maybe with describe this technique in this way. It's a straightforward aggregation of the DP clients, all the DP's clients side APIs. So you must understand, all right? Concept of the DP is simple. Only 3 APIs are available. I'm not sure whether you still remember or not. This one, asynchronous remote eventer, and remote reader. Only three. So you just combine them together, aggregate them together, then the ASS client can be created. If this one is created, then CS server, then the peer is actually for if you program with free, the peer actually the CS client plus the CS server. You must understand CS server. So let us take a look at CS client. CS client. Here, C client, we find a client package here. Client, right? Client. CS client. Right? This is CS client. This is the implementation of CS client. Okay, take a look at here. This is event. This is the sync eventer. I call sync eventer. It's a synchronous remote eventer. You must say this before, right? It's very easy. If you understood, you have already understood what I have done before. Let us take a look at the project we programmed in the previous classes. Okay, let us take a look at this one. Here, eventer, right? Circle eventer, we program this code last class. Okay. Here, a synchronous remote eventer, but the message is a server message. For our case, this is a specific one, okay? And this one is not used here, but we create such one, use this one before as well. This one. This is the eventer, right? Business eventer. This is the first project we program. Okay, for this one is yeah, right? We use this API before, and that's the same, right? The API is same, the pattern is same, right? This is the synchronous eventer. Free client is for TCP client management. This is thread pool. That's the same, right? Put it here. And then we need to initialize the client pool. So this one can be initialized. The synchronous eventer should use the client pool as to initialize it. Here, that's the same thing, right? This is how we can initialize a synchronous event. More parameters need to be used to initialize it. The client pool is shared. We use this client pool. The client pool is used here. They share a single client pool to save the computing resources. Then here, the remote reader is initialized, right? For our case here, remote reader is used in this. We design another singleton to do that. Okay, here we need to initialize the remote reader. But for this case, we need to combine them together. So these three APIs are initialized and combined together. They aggregate together within the constructor, right? Okay. Here I don't need to explain that because there are a lot of parameters. So I design a builder pattern to process, to make the code clean when you use CS client, because there are a lot of parameters to initialize it. So we need to design a builder pattern. This is the code of builder pattern. Here, dispose, okay? It's the same thing here, right? Similar. The constructor is the same. Okay. Dispose. That's the same thing, right? the reader. If we want to close the reader, just call the shutdown method. Shutdown method also invoked here. Okay, this is for this case, the thread pool is we share a thread pool. Usually, it's better for us to share thread pool rather than using a new instance. So here, thread pool is required to initialize the CS client. Here, we need to send a notification through the synchronous remote eventer. Here, we send a notification using the asynchronous remote eventer. That's the same thing, right? Here, the like notification is sent in a synchronous manner. Here, this is a server message. It's all the message parent, right? So here, using this method, you can send any message. So this method is we can use it to send any message. We do not need to use the generics data type to specify one particular message. Here, this method can be used to send any message because they say that we use a parent class here as a parameter to send a message, and here, right here, we can perform read and exercise, right? Read and to send a request and get a response. Both of the message are the parent class server message. That's the same thing here. All right, if we want to read something from the server, the format is the same, right? It's the same. Okay. Here we sometimes we need to the goal for this one is post. It's supposed to whether we want to expose this as a client pool. That means sometimes maybe need to share this TCP client. So to save resources, when you want to do that, you can using this method. So we do not need to initialize many multiple TCP client. Usually for each client, only one instance for such a pool is enough, right? So if you need to share it using the shared TCP client pool, you just evoke this method. So you can see here the TCP is CS client. CS client is according to our definition, it's not, at least it's not the DP, not one member of the DP, but I think TCP client is also advanced API. But it's easy for us to program it, right? When we program such a system, we only use the distributed API at the client side, and we only use the pattern. Although the pattern is very simple, right? That at least for this case, the CS server can be programmed with the distributed API DP only. And furthermore, although the peer a little bit complicated compared with the CS server and CS client, it can, because it's a combination of the client and server. So DP or the peer is also can be created with distributed perimeter distributed perimeter only, right? That for at least we already have two advanced API, the peer and the CS client. Both of them are created are originated with the DP only. If we can we can prove, maybe we can give a simple proof for the generality of the grid free, because all the system is composed. I just mentioned before, all the classical distributed system based on the peer. The peer is originally free from the DP, so it's another evidence that grid free is generic, is self-contained. Okay, today time is up. So if you have any questions, just email me. You can also chat with me through our QQ group. And so next time we'll see how we can implement the code of peer. But I think although you haven't seen the code, I think it already you must be able to implement the code by yourself. Next time I will show my implementation. Okay, that's all for today. Thank you so much. See you next time.